Okay, so we talked a little bit about the client-server architecture before. Now, this is going to be your request response style of architecture, right? Where I have a client, I have a server, the client wants something from the server will respond back, right? So the way that works from the server's perspective is that the server is going to listen for requests. How does it do that? It's going to look for requests for a particular address and a particular port. So if you've never seen this before, basically this is the IP address here. So this 192.168.1.1. This is a unique ID for my computer on a local network. It's not unique internet-wide. This is usually if you have like a Linksys or a simple home router, right? Don't worry, we're not getting into network mapping and all that. But I have a unique IP address. Okay, the server is going to listen for that. It's also going to listen for a particular port. So if I'm serving web traffic, I'm probably sending it out on port 80 or port 443 for secure traffic, or port 8080 for, say, development or additional servers. Basically, the idea is I'm looking for network data to come in at this particular spot. It's going to be the address and port combo here. So I'm going to listen for that, and I'm going to wait for clients to connect to my server. Once that happens, basically the client has made their request clear. I'm going to send them the data back, right? So they're going to request either a line of data or a block of data. Consider this to be like an HTML page, an image, a link, something like that. The server is going to package it up, respond appropriately, which means packaging up this resource in whichever protocol it's using, send it back to the server. Now, send it back to the client. This can either be stateful or stateless. And what this means is that either we maintain a persistent connection, meaning we know the client, we're talking to them, we have basically a pipeline of data going to and fro, or we're just doing a single one-off response every single time. Basically, your pre-web days is the stateless side of things. Or sorry, not pre-web, pre-HTML2, HTTP2. Separate topic. Coffee's running out here very quickly, I can tell. All right, so idea here is that port and address is what we care about. So in this idea of a client-server architecture, we are sending and receiving data. Now the question might be, how did we do this before the web came along? Remember, internet and web are not the same thing. So how did we send data just on the internet before the web came along? Well, we did have multiple protocols that we could use, and they still exist to this day. There's SMTP, which is your email. If you've ever set up, say, Thunderbird or Outlook or something like that, you've probably had to fill in the SMTP fields. That's basically just the address of your email server. POP3 would be another one. We have file transfer, so FTP or SFTP. So this is a file transfer protocol. Tack on an S and it's secured. Recommend that over standard FTP, by the way. You had your news groups, which would be like your old Usenet type things. That goes on the NNTP protocol. We had Gopher. Could have just sent a floppy disk. Insert professor joke of the day. Basically, we just talked on protocols. We had some destination address, some source address, various ports, and the protocol data would go to and fro, right? So what does this actually look like? First one we're going to look at here, and we're not looking at all of them. Just be aware that they exist, and I'll be happy. But one of them is SMTP. So this is the Simple Mail Transfer Protocol. This is how emails can be sent. Basically what happens is you have, again, use Thunderbird or Outlook or whatever your actual email application is, you're going to send a message to the server to be emailed, all right? So we're going to use port 25 for this. We'll be getting into ports very, very soon, but basically the idea is that this port needs to be open in order for data to go in and out of it. If I try to send a different port, send an email on a different port, the server's probably not going to understand it, or it's blocked or something of that nature. Basically, the port number is important. SMTP is nice and easy because it's just text-based, so it's simple. If I have a message that I want to package up, it's going to look something like this. I'm going to start off with hello, mail from, sending email, recipient, somebody else. Here's my data block. Here's my message, and then quit. This is very easy to parse out, right? If I'm looking for data on port 25 and I get a packet in, I'm going to start parsing it out. Oh, hello. Okay. So this is an email. What's the mail from field? Here we go. Split it up right after the colon. Who's the recipient? Here's my data block. Once I see quit, we are done, right? Very easy to parse out with a simple text-based parser. And that's basically what SMTP does. And the idea would be that the email server then just kind of round this out. Once this message is received and we have made sure that everything's in place and good, the server would then send an email to whoever this recipient is, and they would get a very similar message. It would go to their email server, which, depending on how you have things configured, either you pull down to your local Outlook, you go to their web browser, and look at your email there, but it's decoded as an email. It has been sent from computer 1 to computer 2 by way of email servers along the way. Okay. Just to kind of give you an idea of some of the common ports that are out there, this is mainly if you are configuring your server, you need to open up these ports on your firewall. We'll sprinkle in firewalls as we go. Basically, you want all of your ports to be closed because they're typically venues for attack if you leave things open. But you need ports open so that you can communicate. It's kind of a weird balancing act. So 20 and 21, it's going to be our FTP protocols. 22, Secure Shell or SSH. This is how you remotely connect to most Linux servers. If you watch the Google Cloud video, I've got a very bizarre interjection in the middle of the demo where I said, hey, don't forget to open up port 22, otherwise you can't access your server. This is why. We need that port open. All right, you have Telnet at 23. This is basically Windows' version of SSH, except it's horribly insecure and not recommended anymore. Don't use it. It's terribly insecure. And I'll let you read through the rest of these, but basically the important ones that we're going to care about here for web stuff, it's going to be port 80. This is going to be your HTTP port. This is how you browse. For instance, every time you go to, say, efredericks.net or cis.gvsu.edu, it's actually that colon 80 because it's going to port 80. It's just left off because everybody pretty much uses that. Other one, 443. So this is your HTTPS port. It's basically the same thing as 80, except your traffic is being encrypted. In theory, that means it's a lot more secure. But I've got the link here for all the descriptions of those as well. Okay, a lot of information, still very high level. I've got extra info for you on the different protocol stacks as well. Please get through the reading, and other than that, I will see you next week with more videos. Bye, everybody.